Hello YouTube, Ian here. This week I wanted to show you this cool clock I made. This isn't exactly a brand new design, but it's a new revision. What I changed is I added this real-time clock chip, and it's got this battery on the back. There's a little coin cell hiding in there, so when I unplug it, it keeps its time. This is something I've been wanting to do for a while, but I'm just not enough of a programmer to do it. So with the help of AI, I was able to write the code to make this work with that real-time clock chip. So I'm super happy that I've actually got this working finally. This has been on my list for a while. But with that makes this clock a pretty solid design. These are the vintage TIL-311 binary coded decimal displays. Those things are cool because they take a 4-bit binary coded decimal and output a human readable 0 to 9 numerical digit. And from what I hear, they were pretty commonly used and very handy back in their day, but now I don't think they have much use in the world besides clocks and looking cool. And I know good and well there's a bunch of you out there that have some of these sitting in your junk drawer or in your parts drawer. It's not fair to call it that, with no use in the near future. So here you go, you can turn them into a clock. So this board here I designed, and this is nothing more than just a vintage, or not a vintage, but just a video card that I pulled out of an old computer. I guess it's VGA, it's fair to call it vintage, and a piece of wood to hold it up on a stand like that. So yeah, since I've got a pick and place now, I can make these really fast and cheap. So I'm going to put this board on my website as an item. So if you have some of these displays, then you can go and buy this, and it'll come with the firmware flashed and all the components soldered on except the TIL-311s. So minimal effort involved really, just through-hole soldering, pretty easy. And I'll also include a coin cell battery holder. You'll need to provide the coin cell. I don't have enough of them to offer them. Solder those wires onto the battery leads there, and it'll keep its time when it's unplugged. And yeah, just solder it together and it'll just work. I think you can mount these on a video card like I did, or I'm sure somebody will come up with something else creative. I'd love to see it. Real quick, I'll show you the schematic and give you a rundown on how this thing actually works. There's not much to it really, it's just a microcontroller and those displays for the most part. So this is my favorite 328PB microcontroller. I like that one over the 328P, which is common in the Arduino Uno, because it gives you a few extra pins and a few extra features, and it doesn't require an external oscillator. You'll notice there's no crystal in here. So yeah, that's the brains. Down here we've got the DS1307 real-time clock chip. That's where the crystal is that's actually doing the timekeeping. And it's got a connector here going to that coin cell battery, so it has just enough power to keep the time when it's unplugged. And I suspect that battery will last years. This thing doesn't use very much energy, and when it's powered, I don't think it draws anything from that battery. So that communicates to the microcontroller with these two pins over that serial clock line and serial data line. And so when you set the time with the buttons up here, then the microcontroller inputs that and then writes it to this real-time clock. So it actually changes the time there as opposed to keeping the time in the microcontroller. So the microcontroller, as I understand it, is always getting the time from the real-time clock, and all it does is just display it, and it'll change the time if you press the buttons. This over here is the programming header. That's how I program the microcontroller with my little flasher tool. That's a topic for another video another day. Those are just some decoupling caps, 100 nanofarads, 2 of them, and an electrolytic 100 microfarad cap. Some pull-up resistors for the serial data line and serial clock line for this real-time clock chip, and that's just the USB power input. Those two 5.1 k ohm pull-down resistors, that's another one worth another video, but that is a handy trick on these channel configuration lines on a USB-C connector. Just by connecting those two 5.1 k ohm resistors between channel configuration 1 and channel configuration 2 and pulling them to ground, now when I plug like a laptop power supply or a high-speed cell phone charger or really anything that'll fit in that USB port, those two resistors are going to tell the device I want 5.1 or 5 volts, and it just works. So yeah, that's the schematic. I'll open source this, by the way. If you want to make your own, it'll be free for the taking on my website. It's KiCad format, so you'll have to download it and open it in KiCad, and then you can make changes as you want to and order a new revision of the board. So that said, let's get into the assembly. So step one is going to be to apply solder paste. So I'll just go through this real quick. Snap that in there. Those holes are all lined up perfectly with the solder pads. And I'll just spread this out with a putty knife. All right, there we go. That should do it. Now we'll place the parts. Put this in my neodymium pick and place here, and should be all set up. I haven't done this design in a while, but I think I should be able to just press start and it'll do its thing. I just love watching this machine work. It would take me, I don't know, probably an hour of gathering up all these parts and hand soldering them. Uh-oh, got a stuck needle. There we go. It'd probably take me an hour to hand solder this, but with this machine I can do each one of these in about 5 minutes flat. Especially if I'm doing the solder mask at the same time and baking them in the oven. Although these are small enough I could fit a bunch of them in the oven. So we'll just let this run and then we'll pop this in the oven. And there we go, just like that, it's done. So this microcontroller here, that's a setting I forgot to change. I've got those loaded in a different feeder. That's not a big deal. I'm gonna have to fix that for the next one, but I'm gonna have to move this over with a pair of tweezers in the interim for this one. There. Now we'll put this in the oven and bake it. Not too different than baking cookies, really. The oven is all preset with a certain profile that'll hit the right temperatures at the right time. It'll warm up slowly and then warm up some more and then go to the temperature to melt the solder for just long enough to actually melt the solder, and then it'll shut down and cool off. So that's all there is to it, really. Put it in there, press start, walk away. All right, oven's done. Let's see what we got. Nice and toasty, fresh out of the oven. Not exactly a batch of cookies, but I think that turned out pretty dang perfect. I think I'll try and flash the firmware on this next. Okay, firmware is flashed, and all that's left is to solder in these TIL-311 displays. Actually, these are DS1417, which I think is Dallas Semiconductor's spin-off of the TIL-311, and neither of those are still being made. They're long since obsolete, which is what makes these things such sought-after antiques. I've got a little bit of solder on that one. I pulled these out of another clock so that I could upgrade it to this design. Shoot, that one too. But anyway, these aren't manufactured anymore. They're precious antiques. So yeah, I'm just going to solder these in, and this is a little coin cell battery holder. Because these are through hole and this board is pretty small, there just wasn't really space to put this coin cell holder. I probably could have squeezed it right there, but then it would have stuck out the bottom of the board, so I didn't do that. But anyway, for this one I put just these two little battery terminals here, so I'll solder this coin cell battery holder onto those terminals, and that should make it keep the time even when it's unplugged, which is exciting for me. So I'm going to solder these on, and then we'll turn it on and see if it works. Alright, the moment of truth. Plug it in, see if it works. 12 o'clock, that looks good. That's the seconds, so nothing should happen when I press that. It resets the seconds count to 0, which isn't displayed. That advances. We'll just go all the way up to 5 so that I can see, yep, all 6 digits work there. And we can go from 1 to 12. Now, let's see, the real question is, if I unplug it, it's 107. Will it keep the time? It should be 107, and it is. Alright, so there you have it. I'd say it works perfectly. So thanks for watching, and please don't forget to like and subscribe.